Hi, I'm Bob. Thank you for joining me in the tutorial on solving the exercises from the textbook Microeconomics, Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. We will continue focusing on Chapter 14. We will complete the last 3 exercises related to the Cournot Oligopoly model. Here's exercise 3.17. To examine the trade-off between efficiency and market power from a merger, consider a market with 2 firms that sells identical products. Firm 1 has a constant marginal cost of 1, and Firm 2 has a constant marginal cost of 2. The market demand is Q equals 15 minus P. In Part A, solve for the Nash-Cournot equilibrium price, quantities, profits, consumer surplus, and deadweight loss. We use the firm's best response functions to solve for the Nash-Cournot equilibrium quantities and price. Firm 1's residual demand D1R is the market demand minus the output from Firm 2. We then can write its residual inverse demand function. Firm 1's revenue function RR is based on its residual demand, which equals price times its output Q1. Its marginal revenue is the derivative of revenue with respect to output. An oligopoly firm operates like a monopoly with respect to its residual demand. The first-order condition for profit maximization is marginal revenue equals marginal cost. The first-order condition equation is indeed Firm 1's best response function. We can express Q1 in terms of Q2. Similarly, the same reasoning gives Firm 2's best response function. Solving the 2 best response functions simultaneously, we find the Nash-Cournot equilibrium outputs. Firm 1 produces 5 units, and Firm 2 produces 4 units in equilibrium. The market output is the sum of the 2 firms' outputs. Substituting the market output into the inverse market demand function, we obtain the equilibrium price of 6. Next, we try to find the consumer surplus, the firm's profit, and the deadweight loss. As shown in the graph, consumers purchase 9 units at the price of 6. The consumer surplus is the yellow triangle. It is 40.5. To calculate the total profit, we find each firm's profit. For Firm 1, it sells 5 units at the price of 6. So its profit pi1 star equals the price minus its average cost times quantity, which is 25. For Firm 2, it sells 4 units at the price of 6. Its average cost is 2, so its profit is 16. The total profit is 41. The total producer surplus equals the total profit, since we assume no fixed cost. The social welfare is the sum of the consumer surplus and the producer surplus, which equals 81.5. To find the deadweight loss, we need to compare the welfare to the competitive case. The competitive output and price are at the intersection of the market demand and market supply curves. The market supply curve is the marginal cost curve. It should be a horizontal line at the lower marginal cost of 1. So the competitive output is 14. The welfare is the big triangle area, 98. Compared to the competitive case, the Cournot oligopoly case has a deadweight loss, which is the difference between the competitive welfare and the Cournot welfare, 16.5. In Part B, if the firms merge and produce at a lower marginal cost, how do the equilibrium values change? If the firms merge, the merged firm operates as a monopoly with respect to the entire market demand. From the linear inverse market demand function, we can directly write the merged firm's marginal revenue function. Equating marginal revenue and marginal cost gives the monopoly output of 7 and the monopoly price of 8. The firm's profit is the blue rectangle area, 49. The consumer surplus is the yellow triangle area, 24.5. And the deadweight loss is the red triangle area, 24.5. In Part C, we will discuss the change in efficiency, the average cost of producing the output, and welfare, consumer surplus, producer surplus or profit, and deadweight loss. We can draw a table to show the market output, market price, total profit, total consumer surplus, total welfare, and deadweight loss for 3 different market structures: Nash-Cournot duopoly, merged monopoly, and perfect competition. The merged firm's marginal and average cost is 1. The Cournot duopoly firms have a weighted average cost of 1.4. The merger improves efficiency in the sense that it lowers the average cost of producing the output. However, the merger leads to a higher market price and more deadweight loss. The consumer surplus and the social welfare fall after the firms merge. It is the trade-off between efficiency and market power. Let's solve exercise 3.18. The firms in a duopoly produce differentiated products. We know the firm's residual inverse demand function. Each firm has a marginal cost of 1. Solve for the Nash-Cournot equilibrium quantities. We use the firm's best response functions to find the Nash-Cournot equilibrium. Firm 1's residual inverse demand function is as follows. We can write its revenue function, which is based on its residual demand. Then we derive the marginal revenue. A duopoly firm operates like a monopoly with respect to its residual demand. The first-order condition for profit maximization leads to firm's best response function, expressing Q1 in terms of Q2. Similarly, the same reasoning applies to firm 2. We can derive firm 2's best response function. Solving the 2 best response functions simultaneously, we obtain the Nash-Cournot equilibrium quantities. Firm 1 produces 22 units, and Firm 2 produces 14 units. We can also find each firm's equilibrium price by substituting the quantities into the residual inverse demand function. They charge different prices. Let's finish the last exercise in this section. An incumbent firm, Firm 1, faces a potential entrant, Firm 2, that has a lower marginal cost. The market demand curve is P equals 120 minus Q1 minus Q2. Firm 1 has a constant marginal cost of $20, while Firm 2's is $10. In Part A, what are the Nash-Cournot equilibrium price, quantities, and profits without government intervention? We use the firm's best response functions to find the Nash-Cournot equilibrium. We know the inverse market demand function. We can write Firm 1's revenue and marginal revenue functions. The first order condition for profit maximization leads to Firm 1's best response function. Similarly, the same reasoning applies to Firm 2. We can derive Firm 2's best response function. Solving the two best response functions simultaneously, we obtain the Nash-Cournot equilibrium quantities. Firm 1 produces 30 units, and Firm 2 produces 40 units. The firm with lower marginal cost produces more units. The market output is 70. Substituting quantities into the inverse demand function gives the Nash-Cournot equilibrium price, 50. Firm 1's profit is 900 and Firm 2's profit is 1600. In Part B, to block entry, the incumbent appeals to the government to require that the entrant incur extra costs. What happens to the Nash-Cournot equilibrium if the legal requirement causes the marginal cost of the second firm to rise to that of the first firm? $20. If Firm 2's marginal cost changes, its best response function changes. Solving the two firms' best response functions gives the Nash-Cournot equilibrium quantities. Each firm produces 33.3 units. The market output is 66.7. The equilibrium price is 53.3. Each firm earns a profit of 1,111.1. In Part C, now suppose that the barrier leaves the marginal cost alone but imposes a fixed cost. What is the minimum fixed cost that will prevent entry? The marginal cost is unchanged, so the Nash-Cournot equilibrium is the same as in Part A. Firm 2 earns a profit of 1600. If the fixed cost is equal to or greater than 1600, Firm 2 will not enter the market. Thank you for watching this video and subscribing to my YouTube channel. See you next time.